Hey, it's Workbench Quagmire. This is our free code camp Python certification in 100-ish days. As we walk through the free code camp Python certification and work through the workshops and labs. And this is going to be a theory section where we cover what is binary search and how does it differ from linear search. It's a pretty simple concept. And then what is divide and conquer and how does merge sort work? So let's get started. What is binary search and how is it different from linear search? Searching through a list of items is a common occurrence in computer science. We've actually talked about this in the queues and stacks section. There are two key algorithms you should know about when it comes to searching: linear search and binary search. Linear search starts at the beginning of a list and iterates through each item until it finds the target value it's looking for. If the target value is found, the index where it is located is returned. If the target value is not found, -1 is returned. We return -1 because it's not a valid index in most programming languages. Here's the code. What this blue line is. It's interesting. Here's what the code looks like for linear search. So basically, we take an array and a target, and we just walk through that array from beginning to end and say, hey, if this is the target, return that. Otherwise, if we never find anything, we go through this loop through this entire thing, we just return -1. This is basically what we're going to do with the one project that's coming up next, our workshop. It's a little more in depth, but that's basically that. Because you got to, actually, it's not that. It's the next thing we talk about, binary search. If this list we'll search through is 13, 4, 7, 9, and 10, the value 9, target value is 9, the function would return 3 because 9 is at index 3. So 0, 1, 2, 3, there we go, 9. If we change the target value to 5, the function would return -1 because 5 is not in the list. While this is a relatively straightforward algorithm, it's not the most efficient. If you have a large list of items, linear search can take a long time to find the target value. The time complexity of linear search is big O of n, because the time it takes to search through the list grows linearly as the size of the list grows. Grows linearly with the size of the list. The space complexity of linear search is 1 because it doesn't require any additional space to search through the list. Binary search is more efficient algorithm for searching through a large list of items. The conditions here is that the list must be sorted in ascending order. Binary search works by dividing the list in half and checking if the target value is in the middle of the list. If the target value is in the middle of the list, the index of the target value is returned. Otherwise, the algorithm checks if the target value is in the left or right half of the list. It will continue to divide the remaining parts of the list into halves until the target value is found. If the target value is not in the list, it returns -1. So here's what this algorithm looks like. And this is a pretty basic thing. This is something that, like, once you kind of understand it, I have this thing that I do in a lot of programming languages when I'm trying to learn them, when I'm just getting started, and I'll just be like, beyond hello world. It's like, hello world, I print up on the screen. Then if I want to start messing with control structures, like fors and whiles and stuff like that, I'll do this thing called the guessing game. And basically, it selects a random number between 1 and 100, and then you have to guess what the number is. And it's basically this binary search is how I approach it. So let's say it picks the number 34. I'll say, hey, is it 50? And it'll say, no, it's too high. And then I'll go, oh, okay, well, is it 25? And they'll say, no, it's too low. And I'll go, okay, what's between 25 and 50? And then that sort of thing. And this is basically, you could write a solver of that using this. So you have your array. In my case, it's 1 to 100. My target, which is some unknown number. And then what you do is you create a low and a high. In this case, it's the length of the array. Let's say it's 100, right? Well, what's the last index if we start at 0? It's 99. So the length of the array is 100. The actual high will be 99. While the low is less than or equal to high. So as long as 0 is less than or equal to 99 in this case, we run through and we say, what's the mid? well, it's 99 plus 0, floor division 2, so that's going to give us 49, because it's going to be 49 and a half, so it's going to give us 49. If our array 49 is the target, return that index, which is 49. Else, if array, the value at the 49th position is less than the target, then we set the low is less than the target. Oh yeah. So let's say the value, we chose 49, the value is 67. So this is 67, this is 49. Then we're going to set the low to 49 plus 1, 50, right? Because it's not 49. So we add 1 to it, 50. So that becomes our bottom guardrail, kind of our limit. Otherwise, if this is the opposite, where 49 is greater than the target, let's say our 34 case, like 49 is greater than 34, well, it just automatically goes to the else, and it says, okay, well, our high then is 49 minus 1, so it can't be more than 48. So 0 to 48 in that case. Otherwise, if it runs through this whole thing and it never finds anything, we return minus 1. So we return if we hit it, we return if we don't. We start by identifying a low and high index. This represents the range of the list we are searching through. We then check the condition of the low being less than or equal to high. If the low is greater than high, then we search through the entire list and the target value is not found. In that case, we stop the search and return minus 1. If the low index is less than or equal to the high index, we calculate the middle index of the list, mid. We then check if the target value is at the middle index. If it is, we return the middle index. Otherwise, we check if the value at that midpoint is less than the target. If it is, we update the low index to be the middle plus 1. This means you'll search the right half of the list. Lastly, if none of the other conditions are true, we update the high index to be the middle index minus 1. This means we will search the left half of the list. We continue to repeat this process until we find the target or determine that the target is not in the list. Time complexity of binary search is log n, because the time it takes to search through this list grows logarithmically with size of the list. If you remember, that's fairly shallow. The space complexity of binary search is just 1 because it doesn't require any additional space to search through the list. Binary search and linear search can be used for a variety of problems you will encounter in computer science. It's important to understand the difference between the two algorithms and when to use each one. I don't remember it talking about. One of the things that's important with binary searches is that the list is sorted from lowest to highest, especially when you're looking for numbers, right? So makes it a lot easier. What is the main difference between linear search and binary search? Linear search is faster than binary. Nope. Binary search requires a sorted list. True. While linear search does not. Linear search can only be used with numbers. Now, binary search always returns the first occurrence. So binary search requires a sorted list while linear search does not. What is the time complexity of linear search? So the time complexity is 0n because it grows proportionally. It's linear growth. Binary search, what happens if the target value is not found in the list? It returns minus 1. There we go. All right. What is divide and conquer, and how does merge sort work? The divide and conquer paradigm in computer science is a technique for recursively breaking down problems into smaller subproblems. One of the key aspects of this technique is recursion, which happens when a function calls itself repeatedly until a base case is reached. I don't know if we talked about recursion or not. I can't remember. In this lesson, we will look at the merge sort algorithm to better understand how the divide and conquer technique works. Let's say we have a list of numbers. I don't understand why that blue thing's showing up. That's interesting. Say we have a list of numbers, 42, 37, 53, and 17. The goal of this is to sort the list from smallest to largest using this merge sort algorithm. The first step is to divide the list in half. So 42 and 37 and 53 and 17. Then we need to look at the left side of the list, 42 and 37. We take the sub list and divide it in half again until each sub list is only one item in it. So just 42 and a list of 37. A list with only one item is sorted by default. Next, we need to merge each of those one element sublists into a sorted list. So 37 and 42. Then we follow the same process for the right side of the original list. So the right side of the original list was 57 and 17. We divide it in half. We get 53 and 17. We get 53, 50, 17. Then we merge them. We get 17 and 53. Now that both halves of the original list are sorted, we merge those two halves together and sort the elements. Here's the algorithm looks like in code. So merge sort. If the array is less than or equal to 1, then we return the array. So we either return an empty array or just an array with one item. The mid will be the length of the array, floor divided by 2. The left would be the array up to the middle, and then the right is the middle to the end. Sorted list is an empty list. So these are kind of iterators. I call them counters sometimes. I do a lot of VBA coding at work, which is not great, but and I use counter, and sometimes like counter 1, counter 2, things like that. So we have I and J. While I is less than the length of the left side of the list and J is less than the length of the right side of the list, then if I position 0 is less than the right side J at position 0, so let's say 17 and 53, sorted list append I plus 1, else sorted list append J, or the right, and then J plus 1. So that basically we will start looking at the list. If we do the right, we'll start it at the second element in the list, and we'll start at the first element of the list again. So the sorted list dot extend left I. So this is going to be the length to the end, and then the right will be J to the end, and we're just going to put those two lists together and return that sorted list. Time complexity of merge sort would be in log n, because this list is continuously divided in half. Log in and then merge together. Unlike other sorting algorithms, like bubble sort, the merge sort's not sorted in place and has a space complexity of n. What is divide and conquer paradigm in computer science? A technique for detecting a cycle in a function? No. An algorithm for comparing two elements and swapping them from smallest to largest if needed. A technique for recursively breaking down problems into smaller subproblems. An algorithm to compute the shortest connecting network point. I think it's 3. What is the time complexity of merge sort? So it was in log n. What is the space complexity? It is just n. All right, that's the theory sections for this algorithm section. We're done with that. So now it's just going to be workshop, lab, lab. So we'll just got 1, 2, 3, 4, 5, 6 days of work, 7. So that puts us somewhere in the neighborhood of 80 some days. And then we get into here. 1, 2, 3, 4, 5, 6. And then this is 1, 2. And then however long it takes you to do these. So we're going to be maybe just under 100 days. So actually, It's probably a couple of days there, but we're going to be just under a... Yeah, because I don't think any of these are... This one may be 2 parts. I don't think the labs will be, but we'll see. Anyway, thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.